A system of linear equations is a set of equations for lines that we consider at the same time. And what we'd like to figure out is, are there any pairs of numbers, a number for x and a number for y, that make both equations true at the same time? Now, one way to figure that out is to graph the lines. And if we find that there are any points where the lines cross, we've found the solution to the system of linear equations. In this case, the two lines do cross at the point 4, 1. That means the solution for the system is x equals 4 and y equals 1. Since that's the solution, we know that we can take both equations and substitute 4 for x and 1 for y, and get a true statement for both equations. Well, that's pretty straightforward then, isn't it? If we've got a system of linear equations, we just need to graph the two lines, see where they cross, and we found the solution. So let's try that with this system of equations. Now, both lines are in slope-intercept form, so they should be pretty easy to graph. The first line has a y-intercept of -1 and a slope of 3, so it looks like this. And the second line has a y-intercept of 3 and a slope of -4. So here it is. Well, they do cross at a point, but what's the point? It's a little hard to tell, isn't it? That's because the point doesn't fall on an intersection of the grid lines in the graph. In other words, that point does not have integer coordinates. So even though we can tell by the graph that there is a solution, we'll need to find another way to solve the system. And we do have another way. It's called solving by substitution. Here's how substitution works. When we have an equation, we can think of it like a balance scale, where the two sides of the equation have equal weight. For the equation y equals 3x minus 1, the two sides, the y and the 3x minus 1, have the same weight. They have the same value. That means that they're interchangeable, and that's the key to substitution. Because the second equation says y equals -4x plus 3, and the y in the equation we now have a substitution for. We know because of the first equation, y and 3x minus 1 can be exchanged. So when we do that substitution, we have an equation that only has one variable in it, the variable x. So now let's solve for the x. We'll add 4x to both sides of the equation, add 1 to both sides of the equation, and then divide both sides by the 7. And that gives us a solution of x equals 4/7. Well, it gives us half a solution. We still need to know what y is. And to find y, we can go back to either one of the equations we started with and substitute 4/7 in for the x. Once we do that, we can solve for the y, and we see that the y-coordinate of our point of intersection is 5/7. So our solution is that x equals 4/7 and y equals 5/7. Now there's something really important to notice here, and that is that substitution was possible because we had an equation that was solved for one of the variables. That means we had an equation that either said x equals or y equals. That's what allowed us to take the first equation, which said y equals 3x minus 1, and substitute the 3x minus 1 for the y in the second equation. So if the key to using substitution is to have an equation that says either x equals or y equals so that we can make that substitution, what if we start off with these two equations in our system? Neither equation says x equals or y equals. So how do we make a substitution? Well, if we take one of the equations and rewrite it so that it does say x equals or y equals, so that it is solved for one of our variables, then we can make the substitution. And the easier equation to do that with in this system is the first equation. If we subtract the 2x from both sides of the equation, and then multiply both sides by -1, we've rewritten the first equation so that it's solved for y. And we have a substitution for y that we can use in the second equation. When we substitute 2x minus 5 for the y in the second equation, we have an equation with only the variable x in it. And now we can go ahead and solve for x. We'll distribute the 2. We'll combine the terms with the x's in them. 3x plus 4x is 7x. We'll add 10 to both sides of the equation, and then we'll divide both sides of the equation by 7. And now we've got the solution for the x-coordinate of our point of intersection. To find the value of y in our solution, we can go back to either one of the equations we started with, or we can even look at our rewritten version of the first equation to substitute 3 in for the x and solve for y. So the solution of the system is x equals 3 and y equals 1. So the key to using substitution when solving a system of equations is to make sure that one of your equations is solved for one of your variables, either x equals or y equals. And if it isn't, then rewrite the equation so it's in the form you're looking for, so that it's solved for one of the variables, and then you can go ahead and make the substitution and find the solution to your system.